In chapter 9, we discussed the work done by a force, or the work energy theorem. This chapter builds on that concept, and we will talk about potential energy also. So chapter 10 is titled Interactions and Potential Energy. In this chapter, you will develop a better understanding of energy and its conservation. So let's talk about the learning outcomes for this chapter. By the end of this chapter, you will be able to relate the difference between, or the difference of potential energy to the work on a particle for a system without friction or air drag. We call it a conservative, where we just have conservative forces involved. You will be able to explain the meaning of the zero of the potential energy function for a system. You will see that that's an arbitrary choice. Okay? You will be able to calculate and apply the gravitational potential energy for an object near the Earth's surface and the elastic potential energy of a mass on a spring. Okay, you will solve such problems. You may recall from your previous physics course that the potential energy for an object near the surface of the Earth is the mass times the gravity times the height. And the potential energy in a spring is 1/2 times the stiffness of the spring, which is K, and then the amount by which you stretch or compress the spring, called x squared, 1/2 kx squared. You may recall these from your previous physics course. And well, we're going to return to them. We will derive these equations and we will use them. Okay? And you should be able, by the end of this chapter, to use these to calculate make different predictions for different problems. You will be able to characterize a conservative force in several different ways. So first you will describe what is a conservative force and then how to characterize it in several different ways. We will specify the mathematical conditions that must be satisfied by a conservative force and its components. So given a function for a force, you should be able to tell whether that's a conservative or a non-conservative force. Okay, we'll discuss that. You will relate the conservative force between particles of a system to the potential energy of that system. Okay? And then calculate the components of a conservative force in various cases. You see, these topics are a little bit more mathematical here. They involve concepts from Calculus 3. Okay? You might say we didn't do Calculus 3, but we will discuss it. We'll discuss it. You will formulate the principle of conservation of mechanical energy with or without the presence of non-conservative forces. You will use the conservation of mechanical energy to evaluate various properties of simple systems. Okay? That's another goal. You will create and interpret graphs of potential energy. You will explain the connection between stability and potential energy. And finally, describe energy transformations and conservations in general terms. Okay?